and what is normal. Okay, so we're going to look at PK is the 6.1, which is the normal value there. So you just have to look at that. So it kind of shows you that. And then it shows you how they calculate on the bicarb, and we'll look at that a little bit. Then what's going to happen on Monday, we're going to talk about the anion gap. And what happens is that when it's a metabolic problem, we're going to look to see what's causing that problem, okay? So when we get to metabolic acidosis, we're going to see, is that anion gap normal or if it's off? So we'll talk a little bit about that, and that's where you're looking at the potassium, the sodium, and the chloride. So you'll see in the bicarb. So that's why on this here, they asked you to calculate the anion gap, because we did have a metabolic acidosis. So now we wanted to see what was causing that. And I didn't do that yet, so we'll do that more on Monday.
Was it the fire in that case?
Yes, the fire in that case too. Then the rest of the chapter kind of talks about looking at how to interpret your blood gases. And we'll look at, so it talks about the assessment of oxygenation. And if you notice on page 306, he does a nice job of classifying your hypoxemia. 80 to 100 is normal. Less than 60 but greater than 60 is mild. Once you get less than 60 but greater than 50, it's moderate. Anything less than 60 but 50 but greater than 40 is moderate to severe. And anything less than 40 is very severe. So classify your hypoxemia. And then, of course, anything over 100 is hyperoxia. Okay? A greater than what it should be. Then it talks about the changes with age. And then it starts off on page 307 with how to read a blood gas. And it's going to classify how you do the same thing that I've taught you. So looking at the pH. Okay. And then it talks about standard bicarb. Remember that I told you that bicarb is calculated, but if you wanted a real bicarb reading, you would go to the chemistry, and it would give you the standard bicarb. So if I had a retainer and I went to the standard bicarb, I would expect to see a high bicarb there. If I didn't, something's not making sense. So if I looked and I saw that the standard bicarb is normal, but my bicarb is high on this patient, then I don't have a retainer. But if I have a retainer and the standard bicarb is high, bing, 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 I do have a standard. Because remember, bicarb takes ages. It doesn't do it overnight like the CO2 does, okay? So it'll tell you what to do with that.
What is standard bicarb?
So standard bicarb is, you're going to draw it from the chemistry. In the chemistry lab, it'll show you. Then it gives you this nice little conventional chart on how things are going to look, if you like to look at that. Then it gives you some examples of partially uncompensated. So this book uses the word uncompensated instead of acute. Egan might use acute. Goes through there. Then it gives you a clinical focus. What I would do is look at it. So if you were on page 311, it says to me, example 1. I have a patient suffering from a cardiac arrest and was successfully resuscitated. Post-resuscitation blood gases were drawn, and they get. So you get a pH of 728, a CO2 of 32, a bicarb of 14.45, and a base deficit of negative 10.8. Okay. So if we look at this, we're going to see that the pH is down, which is acid. The CO2 is down, which is alkalosis. And we see the bicarb is down, which is acidosis. So we would say that this was a partially compensated metabolic acidosis. Okay? So we look at that, and we see that the patient is hyperventilating to try to get over that. So we see that. So it describes the cause of the abnormal. So we see that the patient has a metabolic acidosis. So now we know that it's a partially compensated metabolic acidosis. So if you look at this, it walks you through how you did it. So if you got it wrong, you could see where you make your mistake. Then it says several hours later, the blood gas was repeated on this patient, and the patient's pH was 735. His CO2 was 30. His bicarb was 16, and his deficit was 8.5. So using the traditional, conventional things, you would see that the pH is now normal or fully compensated. But but it's normal on the acid side. So we know that now we have a fully compensated metabolic acidosis, okay? And we can see that. We saw that for respiratory, then it gives you another example. You've got a patient that had abdominal surgery. So look at your examples in there and make sure that your interpretation matches theirs. And if it doesn't, it walks you through the steps so you can see it. Then it talks about base excess or base deficit. Again, you can see it is defined as the amount of acid or base needed to return the pH to normal or within a normal CO2. Base excess of blood is in vitro is done in the lab, which probably does not reflect changes in the body in the presence of hypercapnia. Base excess / base deficit of extracellular fluid is easy to calculate and is probably a better measurement of the metabolic status than the plasma bicarb. Base excess or base deficit of is taken into account the buffering effect of the red blood cell and is thought to be a better reflection of the entire extracellular fluid, not just the blood. In the case where the bicarb is normal, but the base excess or deficit value is not, we recommend that for the purpose of classification, you use the base excess, and it kind of shows you how they calculate it. T40 is another calculation that we'll look at. Again, it's looking at the metabolic component, and again, it's just simply observing the plasma bicarb minus the bicarb expected to occur due to the change in CO2, and we're going to look at that. Total CO2, we're going to calculate that out. And basically, all you do is take the bicarb and add the CO2 times 0.003. And that will give you the total. Because remember, it's right on page 313. Because remember,
total CO2.
bicarb is, CO2 is carried mostly by bicarb. So that's what you're looking at. So you're looking at the bicarb, how it's total, and what's caused in the dissolved. Okay? Then, of course, it talks about some renal problems. It does the deficits, and then it kind of talks about what respiratory acidosis is, and it walks you through. It gives you some examples. Then it walks you through respiratory alkalosis. It talks about what causes it, which we did in that chart. Then it does interpreting your blood gas system more acute on chronic. What you're going to see is on page 323, what we are going to work on Monday is see the box where it says an effect of acute changes in CO2 and pH. For every 10 increase in CO2, the PO2 pH will drop. That we're going to have to memorize. That we're going to work on Monday. Okay?
On page
323.
Where?
It says
in the black
RC Insights.
Oh, okay.
Then it goes on and talks about acute respiratory failure. It tells you all the things that can cause it, which we did last week. It gives you an example. It gives you some more examples of how they get it. Then it talks about what causes respiratory alkalosis, which we did, and it gives you some blood gas results. And then it gets to the anion gap, which I'm going to do. And then it does the insights, which we're going to talk about. And then it does a combined blood gas, what causes it. And then, of course, your oximetry, which I gave you a handout. I'm not going to do too much on it because you've all done oximetry. And it gave you a handout that talks about the 2 types of cyanoses. I expect everybody just to read that because we did it last semester. And it talks about it here. It talks about oximetry, pulse oximetry. And then it talks about its summary. Good.
Thank you.
Is that making sense?
Yes.
Any questions?
I gotta go digest it all.
Good. Now, what I want you to do is I want you to do the handouts. And then I want to correct yours because I think it's better. I was going to put the answers online, but I think then people just kind of look at it and they don't see it. Whereas when I did yours, I saw your problems.
Yeah.
And I circled them and said, see me. So
Yes.
I want to see yours. I want you to do them, and then I want to correct them because I can then find your mistake before the test. Because I think if I put them online, everybody just kind of looks and says, oh, yeah. And then they don't see their mistake.
Yes.
Whereas if I look, I saw where your mistake was. I can see where your mistakes are and say, see me, or circle them, and you can fix it. Whereas if you look at it, you're on, you say, oh, yeah, oh, yeah. And then you don't find your mistake, and then the test comes, and you make the same mistake because I didn't correct it.
Yeah.
So I want you to do them, and bring them to me. Now, there's many
Yeah.
to practice,
Yes.
okay? Many to practice. I will do the answer sheets for them and bring them to class, and you can check them yourselves. But I really want to see them myself, because then I can figure out where you're making your mistake. Okay?
Okay, thank you.
Alrighty.
I'm happy that I can.
Yes, and it's now on for Monday. Remember the 2 handouts I showed you?
Oh, yeah.
Read those, because now what we're going to see is that some blood gases on Monday have more than one problem going on. So if you read it and see it, it's going to be very crazy, but then you're going to understand why.
So
Okay?
from now on, Martha, you're not expecting us to understand it, but just read it.
I don't expect you to understand that handout. I expect you to read it so that when I start talking about it, it's not Greek to you. So you've read it and go, okay. Because what it's from is, this is my trusty little handbook, Dana Oaks. If